Hello and welcome. I'm Bill Wake. We're here working on a basic game, and I realized I didn't change my date on this thing. Sorry, but it's an old basic game from the '80s, and I'm calling it Swarmed. Today we're going to focus on semantics and environment. So yesterday, we transliterated the basic code to Swift code, but we have a few things like GOSUB and for loops that we depended on support, and we don't have the support yet. So we're going to get that in. And then we got to worry about the environment. The old systems where video was memory mapped, so you just poked values into certain locations and that put it on the screen. And there were other ways too, but the interesting way. So the game's going to look something like this. There's a spaceship near the top. It's in a horizontal row. You can't go up or down, but you can go sideways. And then the stars fill in from the bottom and scroll up as you're there, and you move left and right to avoid the thing. We'll see. We're not close to that yet. Here's the starting code. We'll spend more time looking at it. We're going to refactor once we get this thing into Swift. But it's definitely old school basic. Lots of line numbers, very short variable names, lots of go-tos. There's worse code out there, but this is pretty ugly code. So I want to refactor it and then see if we can modernize it. So yeah, so more stuff. You can see pokes there kind of towards the middle, 2050 or so. SP's the ship, and 238 I think is a picture of the ship. So all right, so transliterate basic to Swift. Well, we've done the part that's dependent on the code I just showed you, but we haven't done the support code yet, so we'll work on that. Simulate the environment. The screen should be pretty easy. The keys, I have no idea what we're going to do there. And then we'll refactor. Okay, so let's get over to the IDE. I ran the test this morning. We've still got a failing test on the next loop, which is where we left off yesterday. One thing I did put an icon on the thing. I meant to do that before, but oh well. All right, so what's going on here? Let's go back to this is our code. Let's find a for loop. Okay, so here's for loop, line 95 for NA equals 1 to 10. And we're just calling some method that's going to deal with it, with setting up the loops, making it so it knows when to repeat. And then somewhere later on, down here a ways, we have next NA. And, actually, we've moved that to negative 131 since it's happening after the LW. So here's the next, the NA address, and what line number to go to next to exit. Okay, so we have to implement these two methods. And where we're going, well, we have this notion of a loop stack that's going to hold the loops, so we have nesting. And we've set up the start variable, so I think the for loop itself, it's okay for now. The next, that's where we left off. So right now our implementation is go to exit, which is not correct. We only go to exit if the loop is done. Excuse me. Okay, so what we have to do then is we should find the entry on the stack. Okay, so this append, because we need to know the skip value and the ending. And if it's good, then we're going to go back to loop. So we need to do that. Okay, so our test, we set up a for loop from NA, starts at 2, ends at 15, skips by 3. And when you say next, the for loop should have set it up to start at 2. We should increment it to equal 5. And then our next line number should be the loop body, which is up here, 101. Right now, we did not increment, and we did not go to the right place. We're going to 200, which is the exit. Okay. Well, as happens, I was thinking about this, and it's like You know, the way we get to this variable is really a little obscure. We could fix that, but let's get through this next loop first. Okay, so something that has to happen theoretically, especially where we are now, the loop that's on the stack is the current one. We don't really need the variable name. Well, we do, but it could be it could be kept up here as well. Okay, so we're gonna have to get the top of the stack, and we're just looking at it for now. So loop stack dot, and it should be last, I think. Yeah, you're supposed to suggest that. Last. Okay. Let's see if I can assign this thing. Var. I'm gonna have to look this up. Swift tuple. Probably this one will have it. I think we can just say var something equals and access it. Yeah. Modify tuple. And we're actually doing this named tuple thing. Okay, so I think we can say, well, I think we can say let what gets pushed, well, ending skip loop equals loop stack dot last. I think that's the syntax. Oh, I need an exclamation here. Yeah. Okay. So we're looking at the top of the stack, the last element, and we want to increment. So the way we increment is loop var sub variable equals loop var sub variable plus skip. Okay. So NA equals and next iteration, whatever it is. Okay. Now, if the loop is less than the ending value, then we're going to go back to the loop address. So loop there is a line number. Okay, so if loop var sub variable is less than, actually, or equal, keep my basic loops correct, it's less than or equal to ending. If it's less than that, then we go to loop. Else, well, we're gonna have to do something else. Okay, I think I can. Let me put this down the line. Okay, else we're gonna go to the exit, and we need to pop the stack. And is it remove? We have last. Is there not a remove last? Remove last, yeah. Okay. And that's redundant. Okay, and actually I can say we haven't tested that, so let's not. And we haven't tested this, so our test only justifies this code. So let's just do the test with that much. I hope it passes. Okay. So now let's increments value twice and repeats the loop. So I want to make sure that two iterations don't interfere with each other. Okay, in address, and I'm just gonna start at a different. Let's just change some values and okay. These shouldn't matter. This is just kind of arbitrarily to make it clear that they don't. Okay, so exit to 500. Yeah, make it 999. Okay, so in this case, I guess the first next loop is really set up for this case. We create the object, we start a for loop, start at 2, end at 20, skip 4, and then we run it once, so it starts 2, now it's 6. We expect it to come out being equal to 10. Oops. Equal to 10, and the line number should be exit 999. Line number should be the 1001. Okay, so the for loop says if you want to execute my body, come here. The next exit says if you don't want to execute, go out there. Okay, so I think this should pass. So sometimes I do these confirming tests just to make sure I haven't messed anything up. All right. And now increment value beyond ending does not repeat. Okay, so if we start at 2, let's skip 3, so 5, let's say it should end at 4. Okay, and I'm not going to do that. Next, incrementing, how about just beyond ending does not repeat. Okay, so start at 2, skip 3. So when you say next, I do expect the value to be 5. I think that's the way the old basics work, but the line number should be 999. Okay, so you should exit. And this I expect to fail. Okay, and if we do this, boy, that remove last, I don't think we've justified that yet. So my theory is this is enough to make this pass. See if the one assertion failed. Yeah, so the 5 is correct. It incremented, but it did not set the go-to. Now we're going to set the go-to. Okay, now, all right, so I think we've done these things. Increment, test whether it's done, and pop. We haven't done the pop yet. Decide where to go. Okay, so I'll clean that out. I think, given that it's mostly working, we're not going to do that. All right, so this remove last stuff, the basics. The next, like, there's no textual relationship. You could have the next in line 10 and the 4 starting in line 50, and then jump back to 10 and do the next. And it's pretty it's pretty unstructured. It's almost the definition of unstructured code. But I think the thing we want to enforce is that if you come in and you say next and you've already finished the loop, you shouldn't be doing that. Sorry, excuse me. So this notion of the stack having this next loop thing and removing it, I want to say, well, I kind of want to test two things. One is if you, let's see, a for loop should put it on there. That's fine. Well, there is a tricky case. If you've already started the for loop and you restart it, there's some semantics there too. All right, but the case we got at hand here, I think if I say next when something, well, if I say next when the variable's not on the stack, right? Something should notice that. Okay. And if I say next after I've already completed a loop, something should notice that. So let's deal with the second one first. No, I guess we got to deal with the first one first. If I say next and you never did a for, something should blow up. Okay, so I think we'll put the error case down here, I guess. I don't know, these tests are similar but just not quite identical. Ugh. All right. So the case is next without for should reports error. All right, so we got a swarm. We got this variable NA. Let's take this. Okay, so if we do swarm next loop, we've not done a for. I expect some sort of error. All right, so I'm not sure how we want to catch this or deal with it. It may be, well, again, like what do these old basics do? They might just exit. They might have a status code. Let's see. I have this manual somewhere. Let me see if I can find it. So my research for this, because this was an OSI, Ohio Scientific small computer, I've got their basic manual. And what I want to find is there's a bunch of error codes. This, I think what you got was the symbol like D ramp, and you're supposed to know that means variable is dimensioned twice. Okay, here's one. Next without for. Yeah, so somewhere, so there's an error code, and we'll even steal the language. Oh, it's not text. Okay. But something went wrong. Okay, and I'm going to say there's an error status, kind of a global status, which I think is what happened with this, and that we're going to force the line, we're going to force it to exit. So let's turn that into code. So let's see, assert wake up Xcode. I can't type that one in any kind of time frame here. Okay, so what we expect is we expect an error code to equal next without for. Okay, we'll just use the old language there. Okay, has no member. And we're also going to assert swarm.line is going to be 0. So 0 is exit and the error code. Okay, so let's give this thing the error. Okay, so error is a string. Okay, starts out empty, ends empty. All right. And this test should fail very clearly. Okay, unexpectedly found null while unwrapping an optional. Yes, that's exactly the kind of error we would expect. Okay. Let's see. I think you could say guard let this equal that else something. Okay. I might have got guard buddy must not fall through. Yes, we are going to do a break. No, we'll do a return. Okay, so something happens there. Okay, so if we can't get the stack entry for this thing, we're going to return. What are we going to do? Well, we're going to set the error equals next without 4, and the line will go to 0 and return. Otherwise, we have those variables, we can just use them and we're good. Okay, so that should pass, I believe. And I don't know where those messages go. I don't know if there's any other for loop errors. Program too big. No, I don't think we'll worry about that. Considering we have, let's see. The old computers had 4K RAM. Of which I think 1K was video memory. So 4K is 10 to the 2 times 2 to the 12th, and 20 is a megabyte. So that's another. Well, that would take you 8, and then a gigabyte would be 10 more, 18, and then probably 16 times that. So 4 more, 22. 2 to the 22, so 2 billion times as much memory or something like that. I think we're okay. All right. Did we ran the test? Okay. Yes. All right. So we're reporting the error, and then this one is next for already completed for. I don't know. Maybe that's a better way to say it. For reports error. Probably not conforming to something, but okay, next. How about on? Already completed for reports error. Okay, so this one, we do need to start the for loop here. Okay, so if I start the loop, NA, start at 2, end at 4, skip 3, and I do a next loop, that's legit. Okay. The problem comes when I do the one after that. Okay. So in this case, 2, it'll run through with 2. We call next. It'll set the value to 5. Realize it should go to line 999. That's fine. Then we say, okay, what if we ran next again, even though the loop is already terminated? We should still get next without 4 and swarm.line. And this should fail. Okay. And this should solve the issue. So we know we have something on the stack. We know we're not well, it's kind of a two-step thing, right? The first time we go through, we increment the variables and go back to the loop. Oh no, the first time through we said no, we skip. So we went to the exit and that was fine. And then we come back in, there's still something on the stack. We increment the loop again. It's not correct at that point. Okay. So I think let's make sure it's not incremented as well. Okay, so sorry, put that down here. Okay, so we did 2. We did 1 good increment. It should equal 5. It should not equal 8. All right, and I'm tempted. Let me put this out and make it fail again. Let's make sure we're really testing this properly. Okay, we expect this to be 8 because it will have incremented twice. Okay. 8, yep. No error, and it didn't reset the line number. Okay. Now, so when we come back in the second time, we've popped the stack. There's no 4 to connect to. We should get the error. The variable should be untouched, and we should be good. Oh. Well, for what it's worth, I think this thing really is like the worst. Oh no. Okay, what am I doing? Fatal variable out of range. Oh. No. What's out of range? Why is that not even... Okay, we did the for loop. Where are we? Here. What? Loop bars, is that... Let's see, are we... All right, I'm very, very puzzled. We'll just run the one test. I don't know of anything that removes loop vars. Swarm. Loop vars 0 value address. Did I delete the wrong stack? Yes, I did. No, I think it should pass. But I thought that last time. Okay. That is good. I think we're doing the right thing. Now, okay, I don't know if I want to worry about the for loop too much. I had notes to myself. One thing is, like, there is a situation where you are in a for loop, you're executing some stuff, you decide, I'm done with this one, and you jump back to the for loop again. And I think we want to make the stack, we want to get your loop out of the stack. And I think there's an argument to be made that you're going to pop the stack until you find your loop. But I think we have that case here, so we probably will have to implement it. But the other thing I wanted to do, so I don't know, yesterday I just kind of, I don't know, wasn't thinking clearly enough. And we even said it, like, well, let's make a map for these variables. So the deal is when you translate a variable, most of them we can just translate into hard-coded variables like var sc and so on. You can tell because they're all caps. But we said, oh, the loop variables, we need to pass the address of the loop variable around and you know, increment it and stuff like that. We can't just make it a hard-coded thing because as far as I can tell, Swift's reflection, we can't easily just go in there and set a variable there. So instead I said, oh, well, we'll just keep the addresses of the loop variables and manage them like this. And I don't know, we even said it, but like, could we do a dictionary instead? And I think that would be better. So we're going to make this, we're going to go by strings now. And that means NA goes to 0 and LW goes to 0. And now we got to find everybody who uses these things. There should be some complaints already. Yeah. Okay. So a loop variable has to be looked up. All right. And then we're going to put the variable in and use it as a string in the rest of this. So let's see if we can get these values mapping first. Okay, so loop var sub NA address. Let's just do loop var sub NA. Okay. Oh, it's optional. Well, I don't think it can ever be nil for a legit variable. So we'll do it this way. Okay, next. So any loop vars, we're just going to do NA, bang. Okay. Hopefully that's okay. So variable. Okay, now we're getting into the trickiness. And same thing down here. Yeah, so I want these for loops. I want this variable to become a string now. Okay. Which means the for loop calls will be messed up. This should become... Thank you, editor. Okay, NA. This one should become LW. Now the next, the variable should be a string. I don't know if we can assign like this. Loop var subvariable. Let's put ending. Okay, our two nexts. Okay, LW. And you can see the mistake. If I had typed it wrong and not noticed, I would have a mess up because of the string name. So I'm using two approaches for variables. If you're in a loop, I'm going to access you through your string name, and if you're a regular variable that I can tell is not in a loop, I'm just going to treat you as a regular variable. And one of my goals is to get this hash loop out of here. Okay, and some tests should break. Okay, so NA and oh well, NA I like being a little more independent like this in a way. It's kind of nice, but strings aren't going to be the best way. When everything's a map, it gets messy. And we could easily mess up something, so if you catch me, and this will have to do that. Surprised it's not yelling at me already. Okay. Now, calling them loop vars, I don't know, I'd be tempted to call them just variables, but okay, so let's see if everything's still working. I really should have pushed before that refactoring. All right, so we did two things. We finished for next, and we changed loop vars to be in a map. Okay, so this for loop case I mentioned, I think we'll leave that for now. Yeah. Okay, so let's go back here. So the other one we haven't really done, goto we did, we haven't done poke and print. For loop should be done for now. We might find out it's not done. And I think what we'll get some weirdness when you go back in, or the stack will blow up or something. So, okay. Delay is not hard, I don't think. So I think we can just do uSleep, and then it's in microseconds. So 1 million is 1 second. But I think we have an integer, and I think my guess is those are either like milliseconds or milliseconds divided by 2. let's see. So what I want to do then is I want to take how long times delay factor. And I'll define that up here, I guess. Okay, and if I did a million, that's, well, let's do 1,000. Okay, and 500 times 1,000 would be 500,000, so that'd be half a second per 500. It like I said, it may be wrong. Let's see. You went there. Okay, I guess we'll go with that. Maybe I could make this when you went 32. See if it likes that. All right. Nope, still wants converted. Okay. Even though we know they will never be that big. All right. Random. All right, let's go back to that manual. Where's random? And it's funny because like all these Microsoft wrote a lot of these early basics, but it seems like this thing just kind of changes over time. Okay, so a number between 0 and 1, it's really 0 up to but not including 1. Random 0 generates the same value always. Random x with the same x generates the same sequence. Okay, so I don't know what This is interesting. So random, this times random 1 generates a random number between B and A. Even though, well, it's really between A and B, I would say, but okay. All right, so I guess we're going to have to figure out the Swift random number stuff a little bit. Random. Actually, I think we can cheat on this for now. Theoretically, if it returns the same value, that's random, right? I mean, at some point in any sequence, if it were long enough, you would see 0.42, 100,000 times in a row. You might be assuming that's not going to happen kind of implicitly, but I think what I want to do is get something running and displaying something. So I think leaving random will work, but GOSUB has got to be implemented. All right, now GOSUB, we need a stack for well, I shouldn't say that. In BASIC, you can't do recursion and you're not passing variables. So you don't really need a stack in BASIC. But I think even still, the easiest way to deal with this is to keep a stack. Okay. So let's create a calls stack. Okay, back up here. And what I'm seeing is kind of well, I guess I don't have any code tests yet. All right. But what I'm seeing is there's parts of this that are generic to a basic interpreter, the way we're transliterating, and there's parts that are specific to the program we wrote. And it would be nice to make this thing, split that up somehow. Okay, but anyway, So we want to make a test for this. Swarm tests. There we are. Okay. The test is something like test GOSUB transfers control. Okay, and if I say swarm.GOSUB, the subroutine is, let's say we're going to call something at line 2000. And we're going to return to line 150. All right, and when you finish that, the line number should be 2000. We should have gone there. Okay, and I don't know, we may have enough of a dummy implementation. This could even pass. GOSUB, yeah, line equals subroutine. Okay, so that's okay. GOSUB is actually pretty simple. It's a lot like GoTo, but the deal is when we get a return, we have to be ready to, well, how about return? I don't know, I'll spell these caps. GOSUB transfers control, return goes back. Okay, so okay, swarm.GOSUB 2000 transferred 150. Now if we do swarm.return, okay, when we get back, we expect the line number to be 150. All right, and the only way it's going to be 150 is if this thing kept it around. This test I expect to fail. So, okay, there's the failure. All right, I like to take a break when we got a failing test so we remember, like, hey, this is what we do when we come back. So let's take a 2-minute break, maybe 3 minutes, and we'll come back and make this GOSUB return thing work and go from there. Welcome back. Okay, so we got this GOSUB. The return is not doing its job. Now I can put that stack in. Okay, so this is var calls. It is just a list of line numbers. I should be pulling that type out too. And it's still going to start out empty. Okay, so GOSUB is, let's see, it's going to push the line. Append. And it's going to give the return address, return to. And then this is really go to subroutine. And this one is go to calls dot pop last. And we'll do the exclamation. Okay. And we know this is not going to be sufficient, but it'll get us through this test. Okay, and let's prove that it's not sufficient. Return without GOSUB Reports error. So we did a return, but no GOSUB. We're going to assert equal swarm.error. And we'll take the language from here. Weird error codes, return without GOSUB. No, there's a colon there and none here. I don't know why. But, okay. And then the line number should be 0. Okay. That should fail. Okay, and we'll do the same kind of thing. We'll say guard let return address equal calls dot pop last, else something happens with a return, and if it succeeds, we're going to take return address. All right, and what we said would happen is return without GOSUB and go to 0. Okay, I think that'll pass. All right, and then one more case I want to worry about. We introduced a stack. Let's at least put a case that checks that we follow a stack discipline, I guess you'd say. So this is really GOSUB and return. So test GOSUB twice. Returns from each. Okay, and I guess this is more like that. Okay, so we're saying we're going to a subroutine in line 2000, and then let's go deeper. Let's in 2500. You should return to 2010. Well, let's go back to this year. Okay, so presumably line 2020 called the second GOSUB. Okay, and if we return, this is one of those rare cases. Normally I do this arrange act assert. This time I want to check things as they come. So I'm going to assert my line number. I guess kind of like this. I'm going to check that the line number should be 2021. And if I return again, I should get back to 150. So we push 150, we push 2021, and we get a return. We should go back to the first one, then to the second one. All right. So, yay, rare case where I don't follow that guideline. And it's my guideline, so I can break it if I want to. Okay. We're good. Okay, so what we haven't done is peek and poke and random. Okay, I try and keep a to-do list, and I am just terrible at it. Okay, so last time, 2021-07-06, this was Swarm-21-01. we did the transliteration. Okay, so this was kind of our goals for the thing. We started addressing for loops. Okay, and I guess this is probably support language semantics. Okay, so we notice we're not touching the code that came from that original basic program. We're touching the code that's just the environment supporting it. So it's kind of like a runtime support. Okay, so today we finished for loops, except possibly restart. Okay, we finished GOSUB return. For next. Okay, and oh, I guess we finished delay in there too. Okay, and what we're doing, that's probably the thing to do now. I think we're at the point of peek, poke, and print. Okay, and now this, I think this is very system dependent. Okay, so I mentioned before, it's all memory addressed, and the way you get to the screen, well, a way to write to the screen is to poke at a certain address, but we can also see something else going on. Let's get down to our subroutine here. This one, we're doing poke 530. Well, I looked all around, and I don't know if it's in the basic or not, but 530 is a special poke. It's nothing to do with the screen. It's to do with the keyboard interpreter. So there's sort of a built-in keyboard thing that turns, well, it's basically the basic language keyboard handling, and it turns, it checks for Control C. So in the loop interpreter loop, it checks periodically to see if you've hit Control C, and then it breaks out of the loop. So it gives you a break functionality. Here's another one. 515 starts a load. 517 turns on or off save. There's just all these little mapped addresses for things. Okay, so 530 is special. And let's see, is that in the other? Maybe that was in this one. I got a lot of weird poking around, trying to find all this stuff. There's people out there still playing around with it. Okay. Let's see. So this basically tells you about the keyboard, or the screen memory. Okay. And poke statements, video memory maps, graphics, characters. Okay. Let's see. Somewhere, well, I have I copied a picture. Let's look at that. We're kind of down to the nitty-gritty here. Okay, so this is the memory map for the 24x24 video card. Yeah. Which is really, times 8, because they're 8 pixels each. All right. But what we can see is 53381 is the start of the screen memory, and 54141 is the end of the screen memory. And so if you poke anything, well, basically in that range. Okay, so I think we can, how do we want to do this? Well, I would certainly like an array. Maybe it's a double array. Maybe not. Maybe it's just a big long array of memory that covers that range. And if you poke something in that range, you write to that memory. Okay, so screen. Okay, so let's, how am I gonna say this? Let's talk about like screen start. Okay, so the test, poke to screen start writes character. Well, maybe even let's start with peak, since we need it to check things there. Peak, well, let's say test screen starts empty. Okay. And the way I can do this, oh boy, is this good or not? I'm going to say for, well, let's do it this way. For 5, let's do swarm.screenStart swarm.screenEnd. Okay, so I'm going to cover that whole range inclusive. Do a for each. Okay, so at this point, $0 is one of these integer values. I got to define these constants. Five, 3, 3, 8, 1, was it? Yes, and 5, 4, 1, 4, 1. And these are both static. Actually, this should probably be static too. Okay. Now, what I should find is swarm dot peak. We got to make a swarm. Okay. Peak of $0, which is the value there, should be a space. Okay, and let's run this and have it fail. Oh, capital 4. Value type close range is number 4. No, it is for each. Swarm.screen start. Why is that ambiguous? Do I have to declare these as ints? No, still ambiguous. What the heck? I'll clean build just in case. Swarm.screen start should be an int and an int. I don't see. Type of expression is ambiguous. Yeah, okay. for address in that. Parameters T. Oh, peak is a byte. Can I do character? I may have to convert it. Yeah. Int of that. I gotta use double quotes there, right? Is that the way to convert a character? Oh. I don't know if that's quite what I want. I don't want to interpret it as a number. A whole number value, that's definitely not what I want. How about Swift get ASCII value of character? Now Swift has these complicated Unicode switch strings. Yeah. Actually, this has a character. How to get a string from an ASCII code. ASCII value of its character. Ort will give you the value of the character. Cool. Except it looks like he's writing Python. Okay. ASCII code value. The ASCII value of this character is sequent 8. Okay, so I guess character dot ASCII value. Do I have to be explicit here? Character this dot ASCII value. Conflicting arguments. And uint probably an exclamation point somewhere too, right? Oh, let's see. Peak returns an int. It probably should return a byte, but okay. This, oh, I can make this int. Okay. And all that, and it should fail. Okay. Right. This thing, we don't need all these prints. And it's returning junk. So, all right. So, I don't know. Let's do a fake it till you make it kind of thing. So, if start swarm.start screen start is less than or equal to address, and address is less than or equal to swarm.screenEnd, then we're going to do something special. We're going to return character space dot ASCII value converted to an int. Suspiciously. Okay, and in our case, we're only storing bytes in there, so I think we're pretty safe. Although ASCII, okay, that's just the screen start. All right. And this should pass. Actually, I don't even know if this is a good test. There's nothing that's going to make the screen start empty. Yeah, I don't think this is a good test. All right, let's do a peek and poke test. And then maybe we can get rid of this one. Okay. Test. Well, let's see. What can I do? Oh, these parameterization things. Let's see. Let's make a screen. And oh boy, I really want it to be int, of type int, and I'm going to have to initialize it. Well, it's really, yeah, I can do something here. Array, oops, repeating and character space dot ASCII value, and the count is screen end and minus screen start plus 1. Is that correct? Okay. If this thing were 1 through 10 inclusive, 10 minus 1 is 9, plus 1 is 10. So there should be 10 items in there. Okay. And it didn't complain about these static variables. Okay, that's good. All right, now let's use that memory. Okay. So if you're in range, then we're going to return screen sub address minus screen start. Okay, so slot 0 is fine. Let's see if this works. I mean, I guess we could initialize it to empty and not hurt anything. Okay. Now, next test, peek and poke. All right, so test peek finds value from poke. Okay, so if I do swarm.poke at, if I do something in this screen start range, value, let's poke 238, and let's make an address out of this. That should be 238. I probably should refine that to say on screen. On screen. Okay, so that fails because our poke does nothing. Poke at somewhere with value. Okay, so we want to say, I guess we got to do the same kind of thing. If you're in the screen range, screen address, your address equals your value. Let's have a little consistency. Okay. And I don't need the print statement anymore. Okay. And we expect this to work. Okay. Let's see. That's peak. Now, I'm not going to address outside of that yet. I know we have to figure out this keyboard input thing. At least something we can live with. But let's get print going. All right, now print, it's, oh dear. So the way print works, let's get back to that picture. What print does is it shifts the whole thing up one line, and then puts whatever you want to print starting there. And I'm not sure what it does if it's longer than the line. It might just push up and wrap, but I think we'll keep it minimal for now. All right, but we do, okay, so we've got to use our little subtraction powers. 3381 to add 19 would get you to 53400. 19 plus 13, 32. So even though the lines are 24 wide, you have to jump by 32. There's stuff left on the edges. And that was a consequence of circuitry and old TVs, pre-digital era TVs. Basically, they were pretty limited in how much you could put across them. You could get 20 in the early computers and 40 in later, and maybe somebody squeeze it to 80, but that's really a squeeze for a typical TV monitor. Nowadays, you got these multi-thousand by multi-thousand pixel displays and all that. So these were definitely not 300 dots to the inch or 900 or anything else. Okay. So I guess that means we have to shift our array 32 to the left, and then right starting at 54117. God love us. Okay. Let's see. So I'm gonna look it up. I'm hoping there's something to move parts of array. Well, if you do it by 1, you can probably do it by n. Yeah. How do I shift elements in an array? A secondary... Oy. Really? There's nothing built in? Okay, let's get over to Swift array. Let's get to the Apple array and see if they've got something. I mean, in C we had like mem move and mem copy and stuff like that. Well, let's see if we can say move. Adding and removing elements. Well, that might be one way. Remove the first 32 elements. Remove subrange. Remove first. Remove the first elements from the beginning of the collection. Okay. Sounds doable. Okay, what's the assertion? Okay, so test empty print shift screen up. How can we tell? Well, yes, I will put that word there. Okay. So what I think we're going to do, we're going to poke something. Let's get over here again. Let's poke something in 53413. No, let's poke something in 53381. I guess if I poke A, B, and I print, I should see B here. And if I poked Z here, I should see Z here. Okay. So we're going to create one. Swarm.screenStart. We're going to poke an A. Well, we don't care what we poke, I guess. Let's poke 50. A 2. All right. And then $32, we'll poke that. And at screen end, we will poke 100. Okay. Now, when we do a print by itself, okay, at screen start, we now expect 51. Okay, what's your problem? Swarm has no member peak. And then 32 less, we expect to see 100. And then I guess we want to prove it. Screen end. It should be a space now, which I don't know. Let's create a little helper method here for this. I don't know what it's taking in. I'll just say int, and it returns a character. No, it doesn't. It returns, I guess the deal is it returns an int. That's kind of what I want to do. Convert a character. Int of ch.ascii value. Okay, so screen end should be character of space. Extended grapheme called literal. Somehow that seems character. I guess this is already a character. Okay, and let's try. Okay. I'm mixing testing and refactoring, and I'm messing myself up. Not a good sign. Okay, and then the last place is screen end minus 31. Oh, but it's not. What's this deal here? D37D. D085. I don't know. The stuff going on beneath this is really screwy. It's 54117 is the number I want. So this 17 plus 3 plus 21 is 24. It's 24 character space. Oy. Okay. This will fail. It'd be amazing if it did anything else. And these 32s, we're going to have to do something about them. Okay, anything failing up there? No. All right, so it's all our peaks. 51, but we got 50. We expected 32 at the end, but we got 100. Nothing got moved. And yeah. Okay. Now let me change this other one. Where did that go? This, let's make this CHR of space. Okay, and I'll just confirm we get the same errors. This one should not fail. Yeah. Oh, not done yet. Okay. All right. So print. Well, let's get the constants in there. Static let screen line distance equal 32. You can see these prefixes. I should say that again. Screen start, screen end, screen line distance. Maybe there's a screen somewhere waiting to break out. It's hard to know what to do. Okay. Now print. Okay, so the first thing it has to do, well, we know we want to screen dot remove first. No. Remove first, yeah, this one. With swarm.screen distance. Okay, so that should move us up one line. Take this out. Okay. And then we need to well, I guess we need to can I append? I want to append a collection. Append contents of, yes. Okay. And then this thing is going to be very similar to what we had up here. Okay, so I'm going to want an array of ints. Well, not going to be exactly that, but we'll just get it down here for now. Okay, so I want an array repeating that stuff for a count. Okay, but I don't want that much stuff. I want to repeat space. The count is swarm.screen line distance, I think. Okay, and we can see this int char of ASCII blah 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 thing showing up here. So probably the test method should move over here. Maybe a better name. Okay, so I think this should do it. I'm a little worried. Well, what worries me is there's actually memory out past here that is reserved for the screen. But yeah, because we got the holes, right? Because this is 53509, 53533. It picks up at 53541. So that's not a distance of 1. That's a distance of more than 1. Because this reflects the borders they put on. Oi. Okay, so I chopped out 32, meaning I chopped out. Yeah, so that's what's funny to me. The memory actually starts back at D000. I don't know what the number for that is, but when I chop out 32, I'm chopping out these 24 plus the 8 that go in here. I guess I'm never chopping out the last line, so I don't have to worry about it in that sense. Maybe that's what's bugging me. Okay. Now, I think we should be passing, right? Okay, that's print, empty print. All right, let's see, what have we done? We've done, well, we did peek, poke, and print for screen. All right, and I definitely want to do some cleanup here. Okay, so first is, let's get this character function, move it over here. Well, it's really, I almost can justify it as an extension of string, or no, character. Okay, so let's get that. Somebody's referencing it. Come on. Care. This is this dot character. Self.ASCII value. And I'm going to change it to toInt. Okay, let's do a build. Build succeeded. I'm not doing this right. Value string. Oh, it's string. It doesn't know it's a character. I don't think Swift distinguishes character and string constants other than by context. Character constant. Boy, maybe I should put that on string. Is that going to do it? String must be round. Okay. Let's see if our tests do okay. Okay. Well, this mess now becomes this dot to int. Swarm-21-02 and then down here we do it again. Oh, I'm going to delete this GOSUB print. Not a perfect solution, is it? Okay. Let's check the print. Print should print a string. All right. One more test on this part. Okay. I guess this is any print shifts screen up. Okay. Test print with text puts it in last line. Okay. This is line distance, swarm.line distance. Okay. If I print A, B, C, D, E, F, G, H, I, J, I'm in O, P, Q, R, S, T, V, W, X. That's 24. I think that's obvious. I'm going to take these pokes out because we kind of proved that already does its thing. And we don't need that. Okay. Let's do this one should be A. And this one should be X. I don't know, is 24 right? If I was at 54141, minus 4 is 54137, 117. Okay, I guess. That one's 5. That one's 24. I feel like I'm off by 1, but we'll see. Okay. Print that. Yeah, that's gonna fail. Okay. 32 and probably another 32. All right. Well, what I'm going to say, tell you what, let's be explicit here. So YZ won't fit. Okay, but we still only see X. So let's make this thing Um, we've removed one line. Okay, so what I want to do is build up a new line. Line. Well, let's call this screen line equals. Okay, and this thing is, I want to, well, let's get to Swift string. There's probably a quick way to do this. I want to blank fill it up to 24 characters, and I want to truncate it to make sure it's no more than 24. Fill. Nope. Okay. So maybe I gotta. All right. Let's do this. Is string. Let's append enough spaces for the whole line. Count screen line distance. That's plenty. Well, let's do it like this then. Oh no, how do we do that? Streamline.append. Append this stuff. Append the given string to this string. Oh, this is not a string. Init. Repeating character count. Okay, so let's repeating space. Repeating space, count, screen line distance. That's the big one, 32. Okay. And then okay, so now screen line is at least screen line distance long. So we can truncate it to, I don't know, maybe we need this other constant. 32 there. So I think we do need another constant. Goodness. And it's the line length. Okay, let's get back down to here. Okay, so we want to say, I guess there's got to be a truncate or something. Can I set the length? That'd be kind of nice. replaces this string with the empty string? Well, maybe remove subrange can do it. Turn drop last. See what range can do for us. Well, remove last can do it too, I guess. So screen line dot remove last characters. Okay. We want to take the screen line length count. Okay, so if we remove that minus screen line distance, okay, have I done this right? So if my string is empty, then I have 32, now I have 24 elements in it. If I remove 24 minus 24, I should remove 0. Okay, if my string length is 24, I append a bunch of stuff. I got 48. Remove the distance. Okay, I think that's okay. So now we can do screen dot append contents of screen line, I think. No exact matches. Dot. Is it Unicode scalars? Did I check in? I hope I did. Okay. The old one was screen dot append contents of the array of ints. Okay, so we got to do the same thing. All right. Hey, I have a plumber coming in a couple of minutes. If they actually show up on time, I'm going to have to make us take a break. I probably should anyway, but that's I hate to take a break and then 10 minutes from now take a break. So, but you know, like my level of expectation of plumbers showing up at exactly 11 when they said 11, you know. Okay. The thing is, we've got a bunch of we've got a giant string, and we need to break it up into ints, I guess, since that's what our screen wants. Okay, so this thing, I don't know if Unicode scalars is the right thing. Unicode. Not found. Oh, I'm not in string anymore. Accessing string elements. Oh, UTF-8 might be good. .21-bit codes. Okay. UDF view is 80-bit encoding. Maybe. Looks like a bunch of numbers. Okay, let's try that. No exact match for append. Let's make sure screen's type is array event dot I don't know, can I map them all? Okay, let's just do map $0. Okay, take the screen line, map it to 8-bit characters, map those to integers, and append them all. All right, there's a long break between passing. And it doesn't pass yet, so I could have screwed it up. What do we have now? 104 is not equal to 65. 104 is like way big. 32 is not equal to 88. Peek at the screen got a 32. Got a 104. Okay, I guess I gotta find what's going on in here. All right, let's step over that. Okay, so let's see our screen line. A, B, C, D, E with a bunch of blanks, and the count should be 2448, but it is 58. Well, that's 26. Oh, plus 32. Okay. Screen line distance. Okay. I don't really need distance, right? I just need the width, but okay. But I stepped over. Now this thing should be down to the letters. It is not. Um, 104. So 32. What letter is 104? Oh, 96 is A, right? So 96 plus 5 should be F is 101. GHI. Okay. Why? Okay, so appending, well, I chose 32, but that's not really quite right. I don't think it should matter, but all right, so my screen line count. Well, I had a bunch of spaces. My screen line count was 58 minus 32. Should be, that's 26, which is still not right, but why am I? Oh, I removed the last 26 letters. Yeah, I'm not removing the right amount of stuff. Well, I don't have to remove it if I okay. Let's stop this. Let's take a slightly different approach. So if I take this out, okay, so if I take the screen line UTF, map at those, and then keep, oh, there's no keep, dot, I think maybe they added that. They don't have keep yet. Oh, that's unfortunate. Oh, what's prefix? Turn subsequence up to the initial elements. Max length swarm dot screen line length. Is that going to help any? Okay, so I get something that's guaranteed too big. And this should be screen line length. Okay. We take our string, we append a screen line's worth of blanks. We map those characters back to UTF-8, which maybe a little flaky. Map that to integers. And then take only up to screen line length and then append that. Okay. It's so hard when you're flipping around between the characters and the strings and the bytes and ints. No. Oh, out of range. No, that's on the peak. 54141. Did I not make this big enough? Screen end 54141. Um 753. What is 54141 minus 53381? What did we decide? 4, so it's 141 plus 19. No, that can't be right. 4. Sorry, that's 619, 719, 720, 820. And it's like we removed. Okay. And then, all right, let's stop here again. Oh my goodness. So I guess my hypothesis, we removed stuff, but we didn't put back as much as we took away. We got to remove line distance. Okay, so when we remove 32, that should put this here. And this here, and more to the point, this here. So we need to prefix it with these missing bytes. Oh my goodness. Oh my goodness. Okay, let's try this. I'm gonna hard code it. See what we got. Oh, and this needs to be streamline distance then. Okay, so I'm going to continue, and I expect one of these to pass and one of them to fail. Oh, actually, our peaks are going to fail, aren't they? Yes. Okay. Golly. Okay, so screen line distance. Okay, I'm going to be trusting. One failure. Okay, well, that's improving. Probably my arithmetic is... Okay, screen end minus 24. Is that correct? 54141 minus 4 is 54137 minus 20, 54117. Okay, let me add an assert. Minus 23 then should be B. And let's take the break. And what else are we seeing? The X was right. So my calculations are wrong. I think maybe this is 23. We'll get an A. I think 141 will still fail. Nothing changed on that. I think 142 will probably be an A. Yes, it's an A, not a B. So this is off. Okay. I want to say this is going to work. All right. Yay. A screen in got to X, which we expected because there's 24 characters. So minus 23, I guess, is the 0. Okay. I think we're done with print. This worries me a little. I mean, I think you're... Well, if you stick to 0 to 127, I think you're okay. And I think basically they're going to... I suppose there could be basic programs out there that print characters, weird characters, but we don't do that in this one. So I'm willing to go with it. Okay. Now let's deal with this out of range thing. Okay. I think I'm just going to put a message in at this point. Okay. Print peek at address. Not implemented. Okay. We don't have... Well, I know the keyboard reading stuff will use this, so we'll go with it. Poke outside screen, not implemented. Value at address. Okay. Shouldn't affect any tests to put a couple prints in. All right. So I think we're either at or close to the point where we can actually run our program. But we have nothing coupling the screen to anything we're doing. Okay, so I have this big screen array. I think what we got to do, now we're getting into the UI part. Okay. Let's see. So add print statements for not supported stuff. Okay. In our to-do, well, we were here. We did all those. We did peek poke and print work for screen. Okay. But what we want to do now is make basic screen show up in real UI. Okay, that's what we're up to now. And well, the easy way, and this is why we may want to pull that screen out at some point, which probably isn't too far down the road here. We're going to make this thing observable object, and we're going to make this a published field. Okay. And what that does is it says, I promise if you ever change me, I will notify you before we get going and give you a chance to redraw, basically. Okay. And so we need, well, I think we can get by with state object swarm equals swarm. Can I do that? Bar. Okay, so I'm creating a variable. I'm going to make this go away. Well, let's put a vertical stack, and we're going to put a screen, and we're going to put a button. This one. Title is go. I guess we'll capitalize it for old time's sake. And we'll give it an action. Get rid of hello world. Okay. I'll put a spacer. And a little space there and a little space there. Okay. Now let's run it. Oh, what's the difference here? Oh, we're making this observable. Okay. Let's do it. Run. What's this? Okay, what did I mess up? Didn't close my VStack. All right, so we expect the word screen and a go button, and it doesn't do anything. Okay, now I think we're positioned. All right, so we got a state object. So now we should be able to walk through the screen. Yeah, okay. So let's go from, oh, okay. A swift range with a step. I think you can do that. Offset by, half open range, yeah. Relative. Stridable. That sounds promising, doesn't it? Okay, I guess we will do that. For, I don't know if I can do fours in these things. For in stride from to by, what's through by, possibly including okay, from swarm dot screen start through swarm dot screen end by swarm dot screen line distance. Okay, can I do this? Type cannot conform because 4 cannot be here. Yeah. Okay, I gotta do. Well, maybe this is the place we stop. What I'm trying to do is walk through our screen one line at a time so that I can walk through it one column at a time. And that'll just be where we pick up, I guess. I may do some research to see if that's a doable thing, but I'd like to do this kind of double walkthrough. Otherwise, I got to transition from my simple array to an arrays, which I know it can handle. All right, we will pick up there next time, which is tomorrow, Thursday, 1 to 3 p.m. Eastern. Thanks for joining me today, and I hope I catch you in the future. Bye-bye.